So here's the example that my math lab gave me for number 8, and we've got samples of size 35. So what we first off we need to do is get the standard deviation for the sampling distribution. They told me the population standard deviation was 5. So to get the standard deviation for the sampling distribution, we have to divide that by the square root of 35. And I did that, and that's what I came up with. Okay. Then we're going to apply this to the problem. So, I mean, for part A, they're asking what's the probability that a sample figure of negative evaluation will have an average greater than so we're doing a sample of 35 people. What's the probability that that sample will have a mean greater than 14.2? Well, for this distribution, we know the middle is the same as the population standard deviation of 16. And we want to find the probability of getting a sample of size 35 with an average greater than 14.2. So here's where 14.2 falls in relation to the 16. And so we want to know greater than that, so we're going to shade to the right. Now you can certainly go back and do this with normal standard scores and use that normal curve table, but there's also, we can use that in calculators here, and that's what I'm encouraging you to use. So for that calculator that I linked to, all you have to do is put your mean there. You have to put in your standard deviation there. Now notice that this is that calculated standard deviation for the sampling distribution when n's 35, right? And then because I want to be greater than 14.2, I selected above and I typed in my 14.2, and that's the area. And that makes sense because here's the mean and here's the 14.2 and shaded to the right. That's just like my sketch that I made. So that's that answer. For part B, they want us to know what's the probability of getting a sample with an average between 16 and 17. So notice I left those same parameters, the same mean, the same standard deviation for the sample sizes of size 35, and I just changed this to 16 and 17, and it graphed it for me, and that's the answer. That's the probability. Again, for part C, they wanted to know below 17. So I left everything the same, just selected below 17, it graphed it so I knew I was looking for the right area, and that's that probability. And it's that easy, okay? The thing you got to remember to do is to convert that standard deviation to represent these different sample sizes.